Good day and welcome to Big Bad Tech. I'm your instructor Jim Pytel, and today we'll commission a basic PLC system. Our objective is to establish a base state to demonstrate applications of the TECO SG2 10HRA PLR, an inexpensive basic programmable logic controller, or PLC. Once installed and tested, we'll use this system to demonstrate various PLC programs without the time-consuming necessity of ever having to physically rewire field input or output devices. PLCs, among their many virtues, are reprogrammable devices, and this system is intended to provide us an ample playground with minimal effort beyond this initial installation and test. This lecture is predicated on the assumption that viewers watch the PLC Interface Methods lecture, available at the Big Bad Tech channel. If you haven't watched this lecture yet, or only dimly recall its contents, please take the time to do so now. Additionally, it is presumed the viewer has some experience with applications of the motor control trainer kit and board up to and including reversing motor starters with interlocks. Finally, it is presumed the viewer has some experience with the TECO SG2 PLR. We'll initiate this application exercise with primary devices configured in the following fashion. A main circuit breaker makes and breaks connection to light industrial 120 volt line to neutral, 208 volt line to line, 60 Hz, 3-phase AC. Immediately downstream of the circuit breaker, a control transformer steps down the 208 volt line-to-line voltage to our chosen level of pilot level voltage, 120 volts AC. The X2 side of the control transformer is ground referenced. Also, downstream of the main circuit breaker is a manual motor starter that makes or breaks connection to paired contactors wired such that the F contactor induces forward rotation and the R contactor induces reverse rotation of the 3-phase AC induction motor. The contactors are mechanically interlocked with one another such that they may not be simultaneously closed. Let's assume the F contactor is on the left and the R contactor is on the right. Additionally, a single overload relay serves to protect the motor from sustained overload conditions. Let's leave the motor unattached for now. Once these primary devices have been configured as illustrated, install the TECO SG2 PLR on the top DIN rail and then route the 120 volt AC control transformer high X1 and the grounded X2 output to the L and N power connections of the PLC. These connections power the internal functions of the device and are ordinarily not illustrated in the schematic. It should be stated that the TECO SG2 PLR must not contain an active program in memory before continuing with the installation. If an inadvertent program remains in memory, upon power up, the device will immediately execute that program with potentially disastrous consequences. Take the time to ensure your device is cleared and stopped before you get yourself into trouble that you cannot get out of. Given this safe starting condition, our intention is to configure the TECO SG2 PLR in the following fashion. The PLC will make use of 6 field input devices: a normally open maintain contact selector switch on input 1, a normally closed momentary contact red push button on input 2, a normally open momentary contact green push button on input 3, a normally open momentary contact yellow push button on input 4, the normally open auxiliary F1 contact of the F contactor on input 5, and the normally open auxiliary R1 contact of the R contactor on input 6. The first 4 field input devices are intended for human-initiated interaction with our system, whereas the auxiliary contacts on inputs 5 and 6 serve as feedback about the status of a particular contactor. Note the maintain contact normally closed e-stop is not a direct input to the PLC, but rather serves as a hardwired bottleneck through which all 6 field input devices immediately downstream of it must negotiate to issue input to the PLC. Wired in this fashion, the hardwired e-stop effectively severs all incoming communication with the outside world without the necessity of resorting to any programmed instructions to do so. Note the schematic shows the field signals kind of disappearing down the rabbit hole of the appropriate PLC input. This is to imply isolation between the field input devices and the PLC exists, and that the PLC program assumes responsibility for all incoming transmissions from this point on. Wire numbers can be used to further clarify points of connection. Note wire 3 is not a single wire, but rather the pooled connection of all upstream terminals of field input devices intended to operate at 120 volts AC. Let's now examine the output configuration. Electromechanical relay output Q1 energizes or de-energizes the F contactor coil hardwired with the normally closed overload contact. Electromechanical relay output Q2 energizes or de-energizes the R contactor coil also hardwired with the same normally closed overload contact. This hardwired connection between the F and R contactor coils and the normally closed overload allows the overload to have the last say as to whether the motor is energized or not, and never surrenders complete authority to the PLC. Wired in this fashion, the normally closed overload contact serves as a means of overriding the program in the event of an overload. Electromechanical relay output Q3 energizes or de-energizes a red pilot lamp, and electromechanical relay output Q4 energizes or de-energizes a green pilot lamp. Again, note the maintained contact normally closed e-stop serves as a hardwired bottleneck through which all field output devices immediately downstream of it must also negotiate to be energized. Wired in this fashion, the hardwired e-stop directly above stream of all field output devices effectively severs all outgoing communication from the PLC without the necessity of resorting to any programmed instructions to do so. Note the schematic kind of leaves unsaid what actually opens or closes the Q1 through 4 contacts. This is again meant to imply that isolation exists between the PLC and the output, and the program is in charge of actually opening and closing these contacts. All a technician needs to do is wire the devices as indicated. Wire numbers can again be used to further clarify points of connection. Note Wire 3's pooled connection has expanded to include all the upstream terminals of the electromechanical relay outputs Q1 through Q4, and that Wire 2 is the pooled connection of all field output device return paths. Additionally, note that the F and R contactor coils are mechanically interlocked together, preventing their simultaneous closure, and both contactor coils are serviced by the same normally closed overload contact. Let's wire this system up. If we do this correctly the first time, always a dicey proposition given the involvement of your lazy lab partner, we theoretically should never have to do this again, and can quickly program and reprogram the PLC as we see fit to perform numerous different functions. First, install the e-stop and 3 pilot lamps, red, green, and yellow in the top push button enclosure. Note the yellow pilot lamp is a place filler and won't be used for this system. Its sole purpose is to prevent your lazy lab partner from sticking their finger in an empty hole. The 4 field input devices go in the bottom push button enclosure as indicated in the schematic. Top to bottom, they are the normally open maintained contact selector switch, the normally closed momentary contact red push button, the normally open momentary contact green push button, and finally the normally open momentary contact yellow push button. Alright, let's begin by routing wire 1 from the control transformer output to the normally closed e-stop. Wire 3 then goes from the e-stop to the first 4 field input devices in the bottom push button enclosure. Note the daisy chain connection pools all these devices together. Wire 3 also pools the 1-3 terminals of the F1 and R1 auxiliary contacts. Now, respectively route wires 4, 5, 6, and 7 from the first 4 field input devices to inputs I1, I2, I3, and I4 on the PLC. Similarly, respectively route wires 8 and 9 from the F1 and R1 auxiliary contacts to inputs I5 and I6 on the PLC. Theoretically, one can now button up the bottom push button enclosure containing the first 4 field input devices and never have to open it again. Let's now move on to the output.